graduated from college in 1919 while waiting for my father to come back from France, where he was gassed in the Meuse-Argonne forest, and he came back a very sick man. His health did not get stabilized until 1930, and he repeatedly was told that he was going to die very soon, after 10 years. We spent 16 months at Fort Lyon, Colorado, when he was in a tuberculosis sanitarium, and he got his tuberculosis arrested. He was never cured, but fortunately he lived until 1954 and did good things without ever working again. But my mother, instead of teaching mathematics and science, spent all of her efforts into keeping him alive for my brother and I. And was successful, obviously. Okay. And Ada was quite a woman. She not only worked with
Can you talk into the microphone so we can hear you?
Okay.
Yeah, can't hear you very well.
Okay. A lot of these people were not very good, and this applies to Newton. I should have mentioned that earlier. He originally had his ideas, what was it? I've forgotten the exact dates at the moment. But it was 20 some years before he wrote those down very precisely. And a lot of these people were guilty of that sort of thing. Babbage was one of those. Babbage gave some lectures in Italy, and an Italian military engineer wrote down a lot about Babbage's analytic engine, and then that was written in Italian. Ada was involved in translating that into English and greatly expanding it with examples, and is considered maybe the first programmer of computers in the world. So I think very highly of her. So is that enough about it?
Because my grandmother, when in England, she lived at Lovelace Gardens, and then I tried to look up about Ada and found out about her.
Yeah. Okay. So we were down to Boole. Boole's wife killed him. They lived 3 miles, and this was in Ireland, from where he taught, and he went in a driving rain to teach, came home,
Wow.
soaking wet, and got a huge cold and things. And his wife in the days thought that if you doubled down on a problem, you could fix it. So she poured cold water on him to boot. And so he ended up dying as a result of that.
Must have been very eccentric.
But it's very fundamental, his ideas are very fundamental to the development of computers, logic, and mathematics. Okay, Dedekind is a very important guy, and I heard a lot about him when I was studying mathematics at Illinois. He invented something called cuts. How many of you ever heard of cuts? You have? Very good. Okay, we got up to the rational numbers, but formalization of the irrationals were a great problem. They refer back to the Greeks. And when I was in graduate school, the way in which the precise definition of the irrational numbers was presented was in terms of Rededecan cuts. And I'll come back to that in a little bit. I won't try to explain them to you because that would take an hour. I'd have to load up on it a little bit. So, anyway, so he was very heavily involved in the definition of the real numbers, which are the irrational numbers, the real. But the reals actually include the rationals. So, okay.
Did he also then define imaginary numbers?
Well, I'm not sure that he did.
Because I was just thinking if he defined the real, that would open up the imaginary.
Cantor is another major contributor. He invented set theory, which is fundamental to all logical operations. Two sets have the same cardinality if you can put them in one-to-one correspondence with each other. To put this in simple terms, if you're in a dance and you try to make up the girls and the boys and put them on the dance floor, if you run out of girls or boys first, they're not the same number. Okay? That's putting one-to-one correspondence in simple terms, right? And set theory is the fundamental logical basis of most of what we do in mathematics today. So he also proved that the real numbers are more numerous. I pointed out that the rational numbers are the same number of those as there are of integers, but the real numbers are of a totally different class. There are lots and lots more of them. So, okay. Peano was another one of the people who helped formalize mathematics. He created Peano's axioms, which are the basis for the precise definition of the positive integers. So it goes something like this. 1 is a natural number. There's a successor to 1 called 1 prime. If two numbers have the same successor, the numbers are the same. And the fundamental last postulate says this. If you can prove something which is the basis of mathematical process of proving things about all of the natural numbers, if a subset of the natural numbers contains a single number, like 0 or 1 today, and contains a successor, then it's the whole thing. Okay? And you can prove something about the things that are based on the natural numbers by proving it for one number, for example, 0 or 1, or even 2, and then proving that if it's true for n, that it's also on that basis true for n plus 1. So once you get on the ladder, by mathematical induction, it perpetuates itself to the whole set. So we got
That's the same guy.
Boston is responsible for that.
Earl, we're getting near the time
Yeah,
of closure.
I'm just about done.
It looks like you want to keep on coming up through the 20th century. And we won't have time to go that far with you.
Okay. So now I got,
Nothing happened in the 20th century.
I don't know how. Okay, I'll try to wrap up. Well, you all know about Alan Turing. So he's been in the news a lot recently. Now, there's one guy here.
Oh, that would have been interesting.
Okay.
That went away.
Landau is a very interesting German mathematician, and he's responsible for two books which were written in the late 1920s in Germany. In 1925, he went to Jerusalem. Excuse me. In 1925, Landau went to Jerusalem to try to help create the University of Jerusalem. He spent some time there then went back to Germany and packed up his family in 1927 and tried to move to Jerusalem. And was supposed to be one of the principal people involved in setting up the University of Jerusalem. Unfortunately, he got shut out of what his role there, and went back, and things were not very hospitable there for his family, so they went back to Germany. And in the process of then, he wrote two books, which were lost because he died in 1938 of natural causes, which is fortunately because clearly he was Jewish. But he wrote these two books. He wrote the best, probably, treatise of that time in the calculus, using the formal techniques that have been developed by all of these people along the line. And then he had his daughter, two daughters who were studying mathematics, and they didn't understand the fundamentals of the number systems. So he decided to write a book, 128 pages, which starts out with Peano's postulates and proves everything about the integers, the rational numbers, the real numbers, and the complex numbers in 28 pages. That's an outline of the book. This did not get translated into English. It appeared in English in 1951. Too late to be of benefit to me, but it basically covers the way I learned mathematics at Illinois in the early 1950s. The natural numbers, 18 pages. Rationals and fractions, 24 pages. Dedekind cuts, critical for doing the real numbers, 26 pages. The real numbers, 23 pages. And the complex numbers, number 43. So
That's it.
and that brings me to my last slide. I wanted to get as many women in this presentation as I could. Grace Hopper is the only one, and someone that I actually knew personally. So I guess that's it. Did I make it? It's 1:01.
Well, it's,
Any questions?
I had a question.
Okay.
I mean, I had read later about the whole dispute between Newton and Leibniz and calculus, and that Leibniz came at it from a different, I mean, they were both valid, but he just came at it from a different way.
Oh, yeah.
But I remember in high school, I mean, has his calculus superseded Newton? I mean, in high school, when we did calculus, it was all, what I mainly remember is integral and differential, which you were
Well,
associating
those
with
are the
Leibniz.
two sides of calculus.
So, yeah, so, I mean, I'm not sure which was which, though. I mean,
They
was-
both
was
had to
Newton
deal
had-
with-
had more to do
They
with
both
what
had to
mo-
deal with both of them.
So there were aspects of both we were probably
Yeah,
getting,
they
but
were-
nobody said, oh, this is Leibniz and this is Newton.
Well, both of them had to deal with differential and integral calculus. They're the two sides of calculus.
Okay, I just, on your little projections, that was the first I saw mentioned was in reference to Leibniz, so I didn't know if,
No,
okay.
Newton had these things.
Okay.
In fact, something else I didn't mention is that in my reading, well, the way in which I was presented was mathematics involves limits and epsilon delta proofs for the basic ideas of calculus. Newton, I found out, actually dabbled in that a little bit, but never adopted it as a basis for what he did. He dealt in what were called infinitesimals. And by the way, the calculus book I had in college dealt in infinitesimals. I never could, I think it was a very poor book, but I was never able to really understand it. When I got to graduate school and got it presented to me in terms of limits, I could understand that. I then went back about halfway through graduate school and picked up my old calculus book and tried to read it. I still couldn't understand it. So, but I was taught the mathematics that is encompassed by all of these mathematicians who worked on this that Hawking recognizes. So, for which I'm very grateful. In fact, after I got out and was teaching, I discovered that those ideas were not fully accepted by people who were teaching mathematics, who were never exposed to that way of thinking. Okay.
I
Thanks for coming.
presume you knew Dale Rummer?
Oh, yeah. Very well.
Dale Rummer was one who came to KU at the same time that I did.